OSPF version 3 Authentication and Encryption. One of the differences between the OSPF version 2 and OSPF version 3 related to the authentication. You know that in OSPF version 2 we have three types of authentication: type 0, type 1 and also type 2. But in OSPF version 3, okay, the OSPF itself doesn't support authentication. Look at here, this is the OSPF version 2 header. As you can see, here we have authentication type and also authentication data. But in the OSPF version 3, we don't have any header related to the authentication. Actually, OSPF version 3 does not support neighbor authentication within the protocol itself, okay? Instead, the routing protocol utilizes IP security or IPsec to provide authentication, okay? Look at here, you know that OSPF is working over the IP. Here I'm going to show you, this is the for example TCP IPv6 model. In TCP IPv6 model, okay, here we have application, we have transport layer, we have network layer, and also we have for example data link layer, and finally physical, okay? You know that OSPF is a protocol that is residing directly over the IP, over the for example IPv6. Here the protocol is the IPv6, and OSPF is working in two for example layer 4 and layer 5. Actually all of the application layer function and also transport layer function is occurring in the OSPFv3, okay? And here inside of the OSPFv3 we don't have the authentication mechanism, but in IPv6 we have the option of the enabling IPsec. Actually, IPsec or IP security framework can be used for securing all of the applications that we are sending them over the IPv6. Actually, we can say that in IPv6 we don't enable in most cases the authentication and also encryption inside of each protocol. We are inside of each application, okay? We are enabling the IPsec, and after that we can ensure that we have authentication, or if you want encryption between two sides. And because of that, in OSPF version 3, okay, we don't need to enable authentication, we don't need to support authentication between two routers, because we can secure the OSPF functionality with the IPsec of the IPv6 protocol. Maybe IPsec is new for you, because the IPsec is one of the security features that you should learn about it in the Encore courses and also in the security courses. But here I'm not going to talk about the detail of IPsec. Only you should know that IPsec is a framework, is a security framework, and in the IPsec we have many protocols. For example, we have encryption protocols, we have hashing protocol, and also some other protocols. Because of that, we can use IPsec, okay, for securing the OSPF version 3. Actually, OSPF version 3 itself doesn't support authentication, but it can uses the IPv6 IPsec, okay? After that, we will ensure that the for example we have an authentication and also encryption. You know that in OSPF version 2 we don't have the option of encryption. Actually, we can only enable the authentication. But in OSPF version 3, okay, we can use the for example IPsec for two style. Actually, in IPsec we have two protocol. One of them is the AH or authentication header protocol. Another is the ESP or encapsulating security payload, okay, as you can see here. If you use authentication header in the IPsec, this means that you want only to authenticate the R1 for R2 and R2 for R1. But if you enable ESP in the IPsec, this means that we want authentication and also encryption, means privacy. Okay, let me to show you each of them. It is a little beyond the scope of this class, but it is informative. Look at here. Here I wrote the configuration that we need for enabling the authentication header. First, I'm going to show you how we can use IPsec with the authentication header, okay, to securing or to authenticating the router 1 for router 2 and router 2 for router 1, okay. After that, in the next scenario, I will show you the ESP. In the AH, or in the authentication header option of the IPsec, we have only authentication, not encryption. But when you are enabling ESP, okay, actually you have both authentication and also encryption. Encryption means we are encrypting the OSPF packets in the R1, okay, and in the R2 we are decrypting the, for example, packets. Let me to show you first authentication header, the AH header of the ESP. The first thing that you should know, maybe you remember from your studies about the, for example, IPsec, we have another function of the IPsec when we are configuring IPsec site-to-site VPN, okay? In IPsec VPN or in IPsec site-to-site VPN, we are using the security association, okay, or SA, and security association means some of the negotiation result that we have between the router 1 and router 2. For example, which method of authentication, which method of encryption, which method of key exchange should use between them. And this negotiation in the IPsec VPN is occurring in the phase 1, okay, and after that we are establishing the IPsec tunnel in the phase 2, okay. Maybe you heard about them. In phase 1 we call it ISA camp phase, in phase 2 we call it IPsec phase. We are using these two phases for the IPsec VPN. But when you are using IPsec for the OSPF version 3 authentication or authentication and encryption, the phase 1 doesn't exist. Actually, we don't have the ISA camp for the OSPF version 3 authentication or authentication and encryption. You should configure manually the phase 1 requirement in both sides, okay, and this is include the SPI or security parameter index, okay. And after that, for example, the authentication algorithm or authentication and for example, encryption algorithm. Let me to show you the configuration of the AH. Actually, we have two router 1 and router 2. First, I'm going to configure the OSPF version 3 between them. After that, we will enable the IPsec between the router 1 and router 2, but with the AH header, authentication header. Here we don't have encryption, okay. We have two methods for configuration. I will show you. Look at here in the R1. First, on the interface serial 10, let me to configure IPv6 address. IPv6 address 2001 db8 12:1/64, and then no shutdown. After that, on the router 2, conft interface serial 10 IPv6 address 2001 db8 12:2/64, and then no shutdown. Now let me to enable the OSPF version 3. First, we should configure IPv6 unicast routing, okay. Router OSPFv3 1, and then here we should use the router ID for example quad 1. After that, interface serial 10 OSPFv3 1 IPv6, then area for example quad 0, okay. After that, in the router 2, let me to configure the same commands, OSPF version 3, then 1 IPv6 area quad 0. Now we will have neighborship between the router 1 and router 2. Here we didn't configure OSPF. Let me to configure it first. IPv6 unicast routing, then a router OSPFv3 1, router ID is quad 2, okay. Interface serial 10, then OSPF version 3 1 IPv6 area quad 0. Now we will have neighborship between the router 1 and also router 2, as you can see here. Let me to show you. Show OSPFv3, okay. Show OSPFv3 IPv6 neighbor. We have neighborship, okay. Let me to enable the authentication, okay, or IPsec between the R1 and R2. We have two methods. The first method is using the interface specific command. On the router 1 and router 2, over the interface serial 10, we should configure this command. Look at here, OSPF version 3. It is so easy. Authentication, that's it. And then here we have some option. We are using the IPsec SPI. Look at here, IPsec keyword, that's it. And then here we have one option, SPI or security parameter index. SPI, we should configure this value same with the other side, 500, okay, or any other value that you want, okay. SPI between these two value. Don't worry about the detail of the SPI and why we need SPI and some other things related to the security courses, not to the NRC course. SPI, for example, 500. After that, which method of hashing you want to use? If you want to use MD5, after that you should give a 32 character password. If you use SHA-1, okay, you should give 40 character password. Okay, for example, I'm going to use MD5. Look at here, we need to use 32 characters as the password. MD5. Here I'm going to use this password. For example, 8212345678, and then 8312345678, and then again, for example, 8212345678, and then finally another 8312345678. That's it. Okay, this is our password. Okay, let me to copy it, and now we should configure the same password on the other side. As you can see, ISACamp is on. We don't have any problem. If do show OSPFv3 IPv6 neighbors can show us that IPv6 neighbors can show us after some second. After 40 seconds we will lose the neighborship. Okay, if you want, you can clear the neighborship. In the interface serial 10, we should use the same command, but I'm going to wait because I want to, that time is passing. Now we don't have neighborship. Okay, look at here, do show OSPFv3 IPv6 neighbor. We don't have neighborship. The reason, because of the authentication now is not passing. Let me to show you the command of authentication, OSPFv3 authentication SPI, okay, IPsec, then SPI. After that 500. This should be equal with the other side. After that, here we should use the authentication method or the hashing method MD5. Then the password. This is our password that we have configured on the other side. That's it. Now ISACamp is up, and as you can see, now we have neighborship between the router 1 and router 2. Do show OSPFv3 and then IPv6, for example, neighbors. We have neighborship. Also, if you want, you can capture the link between the router 1 and router 2. Let me to show you here. In OSPF, we will not have authentication, but in the IPsec we will have, or in the IPv6 header we will have authentication header. Let me to show you. This is one of the hellos. Let me to capture one hello, OSPF hello. Here in the open shortest password on OSPF header, we have these options: version, okay, message type, packet length, source router ID, area ID, checksum, and then instance ID and reserve. That's it. We don't have any option for the, for example, authentication. But in the IPv6 header, you can see that we have AH header or authentication header. And here we have the information related to the hash. Because of that, now we can easily use this method. But if you want, you can use the area based command. Look at here. Here we have used the interface based command. Okay, in the router 1. Let me to show you. Show OSPFv3 IPv6. Then, for example, neighbor. Okay, or show IPv6 interface serial 10. Here, as you can see, we don't have any information about in the last line, but here we have information. Look at here, MD5 authentication, SPI 500, secure socket is up. That's it. It means authentication is passed. That's it. But here at the last line, we don't have any information such as the OSPF version 2. Okay, let me to remove the authentication of the interface. router on the interface serial 10, I'm going to remove the command of authentication. And after that, on the router 2, also let me to remove the command of authentication. Now we don't have any problem. Do show OSPF, for example, v3 IPv6 neighbors can show us that we have neighborship. Look at here with the router 1 without any problem. Now I'm going to enable the authentication with authentication header of IPsec area based. Again, the command is so easy. Look at here in the R1, we can use a conft and then router OSPFv3 1, okay, and then you should use area command. Here you can see the command area in quad 0. Actually, when you are using this command on all of the interface of R1, we have the this authentication method, and this means that on all routers you should use the authentication. If you want to one interface, okay, overriding the role of the authentication, you can use OSPFv3 authentication null. For example, we have configured area-based authentication, but on one interface we don't want to use the area-based authentication. You can use OSPF version 3 authentication null. Area quad 0 authentication IPsec with the SPI, and then for example SPI 400. After that you can use SHA in this time, okay, and here you should use 40 characters, okay, 1 2 3 4 5 6 7 8 9 0. This is 10 character. Again 1 2 3 4 5 6 7 8 9 0. Again, let me to repeat it, okay, and finally we can repeat it one time more. That's it. This is our key. That's it. Now we will lose the neighborship with the router to show OSPFv3 IPv6 neighbors. As you can see, that time is under the 30 seconds. This means that after 24 seconds we will lose the neighborship. In the router 2, we can use router OSPFv3 1, okay, then area, then quad 0. After that, again, authentication with the IPsec, with the SPI 400, with the SHA algorithm, okay? And after that, we can use the same password 1 2 3 4 5 6 7 8 9 0. Again, let me to repeat it. Again, and also one time more. 40 characters. As you can see now, we don't have neighborship. After this command, the neighborship will establish. ISACamp is on, and now we have neighborship, okay. This is the area based command. We can use MD5 or SHA, and here you can easily understand it. Look at here, OSPF version 3 authentication null. This is the means we don't have authentication. And the next command, OSPF version 3 authentication IPsec SPI, the SPI value. Authentication algorithm means MD5 or SHA, and then key. That's it. Here, area ID authentication IPsec SPI MD5 or SHA, and after that key encryption, and after that if you want you can use null. This is the OSPF version 3 authentication. Here we didn't experience any type of encryption, only we experienced the authentication header. Now let me to show you the next scenario. In the next scenario, we can use both the authentication and also encryption. This is useful and this is maybe new for us, because in the routing world, in most cases until now, we have used only authentication header or authentication process, not for example encryption. Encryption means we are encrypting traffics in one time, the OSPF traffic in one time, and also in other type for example site, we are decrypting the traffic. Let me to show you. All right, in this scenario, now we are enabling the authentication and also encryption, both of them. Okay, it is so easy. Let me to configure this scenario from the scratch. Now we have R1 again. We should assign IP address to the serial 10 of router 1, IPv6 address. Okay, 2001 DB8 12:1/64, and then no shutdown. After that, in the router 2, conft interface serial 10 IPv6 address 2001 DB8 12:2/64, and then no shutdown. That's it. Now let me to configure the unicast routing, IPv6 unicast routing. Then router OSPFv3 1, after that router ID is quad 1, and then over the interface serial 10 we should use OSPFv3 1 IPv6 area, for example quad 0. Okay, this is the configuration of the router 1, and then in the router 2 again IPv6 unicast routing, router OSPFv3 1, router ID is quad 2, and after that interface serial 10 OSPFv3 1 IPv6. Okay, then area quad 0. Now we will have neighborship, OSPFv3 neighborship between the router 1 and router 2, as you can see. I'm going to enable the ESP or encapsulating security payload between the router 1 and router 2. This is the configuration. This is so easy. Only we should, for example, do this configuration. In the R1, again, we have two options. The first option is configuring with the interface command, interface-based command, and also another method is the area-based command. First, I'm going to show you the interface-specific command. Interface serial 10. Again, we are using OSPFv3, okay? And here, you know that previously we have configured OSPFv3 authentication. Now we should configure OSPFv3 encryption. That's it, okay? Then, what is the next option? Here we should use the IPsec. If you use null, means no IPsec encryption on this interface. But I'm going to use IPsec. OSPFv3 encryption, IPsec. The next parameter is the SPI, and then, for example, 500. After that, the ESP means I want to use the ESP or encapsulating security payload. After that, here you can see the different methods of the encryption. Triple DES, okay? And then advanced encryption system, CBC. And then DES or null. Let me to use one of them. For example, triple DES, okay? And after that, here we should give the 48 character as the password, as the key of the encryption. This is the key of encryption. Okay, 1 2 3 4 5 6 7 8 9 0. Okay, 10 character. Again, let me to repeat it. Now we have 20 character. After that, as you can see, 30 character. Okay, and then now we have 40 character, and then finally now we have 48 character. That's it. The next statement is the method of authentication. You know that we are using now the ESP for both authentication and encryption. For encryption, we are using triple DES. For authentication, we are using, for example, MD5. Okay. After that, again, we should give 32 character for the hashing. Let me to use simply this password. Okay. A 32-bit means 4 times 1 2 3 4 5 6 7 8. Okay. This is the second time, this is the third time, and finally the fourth time. Okay, that's it. This is the command that we need. Okay, enter. Then on the ISACamp is on, and in the router 2, let me to enable it also. Interface serial 10, again OSPFv3 encryption. Here we should use IPsec, then SPI, then for example 500 ESP, and then the same method, triple DES. After that, 48 character. We should use exactly same key on both sides. Okay. After that, let me to repeat it again. Okay. And finally, we should use this key. This is our key. And then here we should use the MD5 or SHA. MD5 is good. And after that, the key of the hashing. Okay. 32-bit character. 32 characters for the MD5 and 40 characters for the SHA. Okay, this is 32 character. That's it. Now we will have neighborship between router 1 and router 2 after some second, and also we are experiencing the authentication and also encryption. I will show you. First, do show OSPFv3 IPv6 neighbor can show us that we have neighborship. Do show OSPFv3. Okay, OSPFv3 IPv6 neighbor. Yes, we have neighborship. Also, let me to capture the link between the router 1 and router 2. This is informative. This is the link between router 1 and also router 2. Let me to show you here start Wireshark. Okay, I'm going to show you the encrypted traffic. Okay, Here now, as you can see, we should find some OSPF packet. Look at here, this is the OSPF packet, but this is encrypted, as you can see. Here we don't have any information useful for attacker, okay? This is the encrypted OSPF packet, OSPF hello packet. That's it. This is the first method. Also, if you want, you can configure the ESP or authentication and also encryption with the next method. The next method is the, for example, area-based command. I will show you. Here on the router 1, first, let me to show you the show OSPFv3 IPv6 interface serial 10. Here you can see triple this encryption, MD5 authentication, SPI is 500, and secure socket is up. Okay, let me to remove the previous command on the interface serial 10. This is our command. I'm going to remove it, and also on the router 2, we can remove it again here. Now let me to enable the authentication area based. Okay, router OSPFv3 That's it. And then here we should use this command. It is so easy and so similar. Area quad 0. Okay. Then again, we should use encryption instead of authentication. Means I want encryption and authentication. Okay. Then IPsec, then SPI. For example, 400. After that, ESP. And then the next method, for example, we can use here advanced encryption system, CBC. Okay, now, for example, I want to use the 192-bit key. That's it. And because of that, again, we should give 48 character. Let me to use 48 character. Again, we can use this password. This is the encryption key, actually. And then, okay, one time more. Okay, 40 character until now. And now we have 48 character. That's it. Then we can use, for example, SHA-1 now with the next method. Okay. And here we should use 40 characters again. This is for hashing, not for the encryption. 10 character. Okay. Then 20 characters. You know that you should use secure key. Here we are only practicing. And then this is the 40 characters. So easy. Let me to go to the router 2. In router 2, again, we should use the same command. Router OSPFv3 for area quad 0. I want to enable encryption with IPsec. SPI is 400. And with ESP, encapsulating security payload, the method of encryption is advanced encryption system, CBC. And after that, I want to use the 192 key. And then this is the key. Okay, first 10 characters. After that, for example, 20 characters. And then we have 30 character. And finally, we have 40 character. Okay, as you can see, 48 character. That's it. The method of authentication is SHA-1, and again we should use 40 characters for the hashing. Okay, this is the 20, and then 30, and finally 40. Okay, as you can see, after some second we will have neighborship between the router 1 and router 2. Yes, we have neighborship, and you know that this neighborship is a secure neighborship because we have both authentication and also encryption. Show OSPFv3 IPv6, okay, can show us for the area quad 0. We are using the encryption, okay, with this method, advanced encryption system, CBC 192-bit, and the method of authentication is SHA-1. And after that, the SPI number is 400, and this is so easy. This is the authentication in the OSPFv3. Actually, now you know that OSPFv3 does not support neighbor authentication within the protocol itself. Instead, the routing protocol utilizes IP security or IPsec to provide authentication and also encryption. IPv6 authentication header or encapsulating security payload extension headers may be added to the OSPF packet to provide authentication, integrity, and confidentiality. Okay, you know that with authentication header we are providing authentication, and with the encapsulating security payload ESP we are providing the authentication and also encryption. In this picture, we can see the IPv6 IPsec packet format, but the detail is not important for this class. Payload OSPF version 3 with the inner IPv6 header means the source IPv6 destination IPv6 now should be added with the ESP header and also AH header. Okay, and finally maybe we have outer IPv6 header. The detail is not important for this class because this is related to the security courses. And now we can understand that one of the benefits, one of the efficiencies about the for example OSPFv3 in compared with the OSPFv2 is supporting the more secure methods of the authentication and also encryption. You know that in the OSPFv2 we can use hashing algorithm, but this method using the IPsec is a more secure method, and also you know that here we have the option of the encryption. The encryption option is not available in the IPv4 in all of the routing protocols, and now you can, because we are using IPsec, we have this option. Actually in future you will see that in applications we don't have the option of authentication or some other things, because we can use the benefits of the IPsec in the IPv6 protocol for securing such as the authentication and also encryption.